Hello and welcome to this new section. So in this section we are going to make two functions. First is linear function, linear search function, and another is binary search. Okay, so we'll first do the linear search. So for that I should define boolean, or we can say the bool linear search okay. So what type of arguments we need to pass? First is structure arr array, and because we do not need to do any modifications, so we don't pass it star value. Okay, and int element. Okay, it's very simple. We just need to perform the operation like for int I is equal to 0, I is smaller than your arr dot length, and then I plus plus. Okay, and then return if arr dot capital A is of I is equal to element, then we return true. Okay, so if this pointer will come out of this for loop, so it means that it does not contain any element, so we return false. Okay, let's check this thing. So let me first remove this. Let's define status, and in this linear search where we need to pass array, and let us suppose an element 6. Okay, so status is your true and false. Okay, so linear search, let's do the compilation part. So this is your so let me first give you the size 10 and number of elements is 5. So let me first give the elements, give it different, 7, 8, 12, 21 and 6. Okay, so yes, it will give you status 1 means true. Okay, so you all know that for true it is 1 and for false it is. Let me first see the false part as well. Okay, so let me define the 5. If we define 3, 4, 2, 1 and 9, the status is 0, so it is false. Okay, because 6 is not present here. We want to search the element 6. Okay, so 6 is not there. So this is your concept of linear search. Now let's see the binary search. Okay, now let's perform the binary search. So bool type, so binary search, it is also bool type. So struct array arr comma int of element. Okay, so for this we need how many pointers? We have seen in this section that we need 3 pointers, low, high and mid. So let me first define these 3 pointers. What are they? What are those? So for we define low as 0. Okay, and int high as your ARR of length minus 1. Okay, so for that, because length, as we have seen that it is 15, but the index value we have to take. Okay, so length minus 1, we all know that. And for mid, before we going into mid, we need to first check this thing, that while low should be smaller than high. If low is smaller than high, then we can able to perform our rest operations. Like, what are those operations? That mid is equal to your low plus high and divided by 2. Okay, and we need to check if ARR dot A of mid, if it is equal to the element that we need to search, then we need to return true. Okay, else if ARR dot A of mid, if it is greater than the element, then what we need to do, we just define low, we just define high as mid, and otherwise the rest we know. We don't need to define this information. Okay, it is just for understanding perspective. So we can define it here, that low is mid. Okay, we have seen this functionality. Okay, and this is your functionality. Okay, so if in this while loop, if it exits, it means that there is no element present, so return false. Okay, so again it will do until the low is greater than high. Okay, now let's do this. So let me first define the status. Control C and binary search. ARR, comma, if we want to search, let us suppose 6. Okay, so now let's run this. Oh, we don't define mid, so let me first define mid. I forgot to define this. Okay, so now let's give, so this is your 6. Okay, so 5, and we want to give 6 3. Oh, I forgot that your binary search should be in ascending order or in descending order, otherwise the it would not give you the exact results. Okay, 34 and 79. Okay, it's in the sorted order, so it will give you the status 1. Okay, it will give you status 1. So it would give the exact results. So this is it for this section. We'll see you in the next. Happy data structures.